Okay, question 4 is your proof by induction question, and it's one of the summing series type questions, which are probably one of the easier ones to do, so that's quite nice that that's come up on this paper. And the procedure is as it always is, so starting off, checking that the base case is true. And the base case, I'm going to take n to be 1. So is the left hand side when n is 1 equal to the right hand side when n is 1? So on the left hand side, we've got the sum from just 1 to 1, so just the first term of this, which is going to be 1 over 2 lots of 1, which is 2, take away 1, so 1 times by 2 lots of 1, which is 2, plus 1, which is 3. So on the left hand side we get a third. On the right hand side, what do we get? On the right hand side we're going to get 1 over 2 lots of 1, which is 2, plus 1. So that's also a third. So the left hand side is equal to the right hand side, so the base case is true. Okay, so the next step is we then assume that the relationship that we're given is true for some value k. So we're going to assume that this is true for n equals k. So we're going to assume that from, I'll do it down here. So this is our assumption that for 1 to k of 1 over 2r take 1 times 2r plus 1 is equal to k over 2k plus 1. We're going to assume that that is absolutely true, and we're going to find out if it's true for the next term. So is it true for n equals k plus 1? Well, let's find out. So n equals k plus 1 would just equal from 1 to k plus just the next term after it. So we've got all these terms, 1, 2, 3, up to k. The next term would be k plus 1. So we've got that, that's this. So the sum of all of these would be the first k terms plus the k plus 1th term. So I can split this into the first k terms and then just plus the term after that. And the term after that will be just putting k plus 1 into here. So if we put k plus 1 into there, we're going to get 1 over 2 lots of k plus 1 take 1 times 2 lots of k plus 1 plus 1. So we know this, we've assumed that this is equal to k over 2k plus 1. So I can now swap that. And if we tidy this up now, we're going to get 1 over, this is going to be 2k plus 2k plus 1. And this is going to be 2k plus 2 plus 1, 2k plus 3. So is that equivalent to what the sum of 1 to k plus 1 would be? So if we go back to this, what would it look like if we were looking for the k plus 1th term? We're expecting or hoping to get k plus 1 over 2k plus 1 plus 1. That's what we're aiming for it to look like. So if we can make the bottom, if we can turn it into one fraction and make it say k plus 1 on the top and 2k plus 3 on the bottom, then we've done what we need to do. So can we make our thing look like that? Well, looks like we're going to need to add the fractions together. So if we've got a 2k plus 1 factor on the bottom, so if I times this by k plus 3, sorry, 2k plus 3, then we'll get it all over 2k plus 1, 2k plus 3. So this is a quadratic on the bottom. This is also a quadratic on the top. So if I expand this out, will it refactorize to something that we want? 2k squared plus 3k plus 1. Yes, it will, because that is 2k plus 1 all squared, I think. Yeah. So one of these brackets, top and bottom, will cancel, leaving us with 2k plus 1 on the top, 2k plus 3 on the bottom, which we can rewrite like we said before as, oh sorry, I don't mean 2k here. That would have given us 4k squared. 2k plus 1, so that's not 2k plus 1, that's k plus 1. Over 2k plus 3, which we can write as 2k plus 1 plus 1, which is what we were aiming for. So, and that is equal to the sum of 1 to k plus 1 that we were looking for. So it is true for it is true for n equals k plus 1 if it's true for n equals k. But we can say that it is going to be true for n equals k because we've checked it for the first term. So what we've basically now done is we've said, well, it's right for the first term. And if it's right for the first term, then it's right for the second term. But if it's right for the second term, then it's right for the third term. And if it's right for the third term, it's right for the fourth term. So we've got this domino effect. So that tells us now that it's true for any term. And it's really important that you put this conclusion at the end of your proof by induction question to get the full marks. So since true for n equals 1, it's true for all n greater than or equal to 1.